Oop, let's move me. Okay, guys, looking at 125 here, our last page, which I may have said that in the last one. I totally forgot this page was back here, but I felt like maybe we could use a little help, little extra help with the circular stuff. Sometimes pi can be real tricky. Okay, so looking at 125, the three sort of circular things that we did were cylinders, which are like low-key prisms with two circle bases. We also did cones, which cones are low-key pyramids with one circle base. Oh my gosh, sorry about that. They always come in pairs. Hopefully there's not a third. And then lastly, we just talked most recently about spheres, which are circular circles. I don't know, just the three-dimensional circle. So, and we have all the formulas on there. Now, surface area for a cylinder, you guys, is really 2b. Oh, nope. 2b plus pH. That is what's going on here. But the perimeter of a circle is really circumference, so that's why 2 pi r. And then over here, when we think about base, the area of the base, it's pi r squared. And volume is still base times height, but the area of the base of the circle is pi r squared. Same thing for our cone. It's still a pyramid surface area, so area of the base plus the lateral area, which is half PL. Now, P, or perimeter for a circle, is 2 pi r, circumference. And so the 2.5 go away, and that's why we just have pi RL, which, like, that's the fancy L. I'm sorry, it's not a fancy L right here. Don't be confused with a 1 or an L, normal L. It's a fancy L. And then for volume, it is 1/3 area of the base times height. But I can just put the 3 under and make it look like a denominator. That's fine because the top is a 1. And also, like, capital B, area of the base, is that pi r squared. And then the sphere stuff is the same. So 4 pi r squared for surface area and 4/3 pi r cubed for volume. So we'll just do a couple more practice ones because, again, pi can be weird. So looking at my cylinder here, we're going to do surface area first. So that is 2b plus pH, where capital B stands for area of the base. The base shape is a circle, so pi r squared, plus perimeter of the base, which again, since the base shape is a circle, 2 pi r, or circumference, is how we find that. So really looking through this, I just need the radius and the height. I can definitely see the height of the cylinder is 8. However, they kind of didn't give me the radius. The 5 root 2 here is not the radius, but these two legs of that right triangle there are radii, and they are equal, making that a right isosceles triangle, or a 45, 45, 90 triangle, which the root 2 is supposed to be on the hypotenuse, and it is, so your radius is just 5. And so then we can fill everything else in, and then just follow good order of operations. So we want to square it for 25, and then double it for 50 pi. And then over here, when I multiply, I get 40, doubled is 80 pi, and then the sum is 130 pi. I'm going to leave it in terms of pi. Oh my word, inches squared. I'm like writing on air right now because my notebook is so thick. Now for volume, we want to do area of the base times the height, which actually the area of the base I kind of already know is 25 pi. So that made it a little easier. And then the height of the cylinder was 8 again. So if I have 8 quarters, I have $2, so 200 pi inches cubed is my volume. So it's kind of nice when you have to find both because you already really have half of it. Like find both surface area and volume of a thing. If you do surface area, then you kind of have part of volume already. So working a little backwards, if they tell me that the volume of a cylinder is 36 pi yards cubed and its height is 4, find the surface area. Well, let's start with volume because that's what they told me. Area of the base times the height. Since the volume was 36 pi, we can put that in for V. I do not know the area of the base, but it is pi r squared. They did tell me, however, that the height is 4, and so that's kind of helpful because if I want to solve for r, which I do if I want to find surface area, I can now because I have everything filled in except for r. So over here we'll divide the 4 and the pi because both those things are being multiplied. And that's nice because the pi's will divide out and 4 into 36 is just 9. Which is also super nice because now I want to square root, and I get that r is 3. My radius is 3, which again is helpful because now if I think about finding the surface area, we're going to do 2 times the area of the base plus perimeter times height. And I wouldn't have been able to do that to start with because if I wanted to find the area of the base, pi r squared, I didn't have the radius. And also if I wanted to find the perimeter of the base, 2 pi r, I wouldn't have had the radius for that either. The only thing that I had was the height of the prism, which was 4. But going through and solving, the information that I was given about volume helps me to get r is 3. So 3 can go here and also here. So I end up with 9 times 2, so 18 pi. And then 6 times 4, so 24 pi, for a total of 42 pi units, yards, they told me, squared. Okay, so thinking about a pyramid instead now, or I guess a cone, if I want to find the surface area of that, we're going to do area of the base plus half PL. So my base shape is a circle. To find the area of a circle, we got to do pi r squared plus half PL, which perimeter here is circumference, so 2 pi r times L, the slanted height. Okay, so hopefully I know all the things. I can see that my radius here is 1, which is so weird. Ooh, also the 2 and half can cancel out. So just pi times 1 times, they did not give me that slanted height. But I can find it because I have a right triangle here. And so I end up doing 1 squared plus 2 squared equals that hypotenuse that I do not know squared. So 1 plus 4 is 5. And then I square root it, for a slanted height of root 5. So when I finish this problem up, 1 squared is 1, times pi is just pi. This right here, when I multiply all the things, is just going to end up being root 5 pi. And I kind of can't add those right now. Like they're both pi's, but they're not both roots of 5. So really the actual surface area is pi plus root 5 pi meters squared, which I mean, that's real gross. Like I probably should just get the decimal for that, but I'm too lazy. When we think about volume, we got 1/3 area of the base times the height, which this is true height now, not slanted height. So 1/3 area of the base I found was actually just pi r squared. That was just pi. Times the true height, which is 2. And so really my denominator is going to stay 3. My numerator is going to be 2 pi. Like, that's it. That's your volume, meters cubed. So 2/3 pi meters cubed for that volume. Alrighty, so thinking about a backwards type problem. If a cone has a volume of 432 pi centimeters cubed and a height of 9 centimeters, find that surface area. So if I want surface area of a pyramid or a cone, you got B plus half PL. Area of the base is pi r squared. Perimeter of the base is 2 pi r. And then we have our slanted height at the end. The 2.5 can go away. And like, this problem super sucks because I don't have radius or slanted height. And I need both. So we have to use the information that's given, which is volume. So if I think about how we find the volume, instead we have 1/3 area of the base times the height. And they've told me that the volume is 432 pi. And then the height is 9. Now to find the area of the base, I have to do pi r squared. So I am able to fill in all the things aside from r, which will be super helpful and also feels like not enough. Like I still need slanted height. We'll get to that. Don't worry. So I am actually going to take 1/3 of 9 because I can. It's 3. But then over here, I'm going to have to divide those things away to get r alone. So I'm going to divide by 3 pi on both sides. So then we just have r squared left. Boop, boop. Now the pi's divide out, and 3 does go into 432. Let's see, 1's here, 4 times there, 144. Oh, that's so nice, because then when I square root it, the radius is 12. Now, if we think about a cone, and my radius being 12, and then my height being 9, I can find that slanted height because I have a right triangle. So we can do that Pythagorean theorem thing again. 9 squared plus 12 squared equals, I don't know, squared. This might actually be a triple. So we got 81 and 144 for 5, 2, 3, 25. Maybe it's not. 225, just kidding. That's too much. 225, so maybe it is. It's 15. So that slanted height is 15, which is helpful because now I can find the surface area. So we found that our radius was 12, so we can put that in for r in both spots. Also, our slanted height was 15, and so we have 12 squared for 144, plus the 12 times the 15, sorry about that, big number anyway. I want to do 12 times 15 on my phone, 180. And they are both in terms of pi, so I can add them up for 324 pi as my surface area. Oh my goodness, centimeters squared. Oof. Last but not least, and like those ones are tricky, guys, because we're working backwards to get something and then plugging it in and going forwards. Last but not least, we have our easy ones. I think spheres are easy, but again, anything with pi, oh, I don't know what I just did there. I just took a picture of something. Don't know why. Oh, uh-oh. Go away. Uh-oh. Oh no. Oh no. Hopefully we can get that back here in just a second. I'm so sorry, guys. So annoying. Ah, here we go. Okay. Sorry about that. I don't know what I hit. Let's try our surface area and volume of our spheres. So, oh, this one is a little tricky. Okay. So for surface area, we have 4 pi r squared. But actually what they've given you here is the area of your great circle. So again, that great circle is created when I cut it right in half, like that two-dimensional slice that we talked about at the very beginning of the chapter makes a circle, and this is the biggest one you can get. But I can set that equal to how I find the area of a circle, which is pi r squared. And maybe I can just see what r would have to be. But like we divide the pi's away and then square root for 7. So then I can just plug that in, and we have 4 pi 7 squared, which is just going to give me that 49 back. But then I have to multiply it by 4 rather. And if you remember the baseball, that kind of makes sense because like if I'm peeling the circle away, I kind of get these 4 big circles laying flat. Like if you unstitch the baseball, I think I showed you guys that picture. So 49 times 4 is 196 pi meters squared. And then when we want to go find the volume, we're going to do that 4/3 pi r cubed, which I kind of want the r for this one. I know it didn't change when I went to area, but I do need radius so that I can cube it up because that's going to be different than this radius squared number. So times 7 to the 3rd, and I do need to do 7 to the 3rd first. So like you can multiply them all out, but there is a little to the 3rd button. And then I always try to divide that by 3 because like we are dividing by 3. But if it doesn't go, then I go back to it. So 7 to the 3rd. And I times it by 4. And then I just leave it over 3. Now, the thing is, if that initial number wasn't divisible by 3, when I multiply it by 4, it's not going to magically become divisible by 3. So the exact volume here is 1372 over 3 pi meters cubed. And so then last but not least, let's get another little backwards problem going here. If a sphere has a volume of 7776 pi meters cubed, find the surface area. Okay, so if I want surface area, I need to do 4 pi r squared. They didn't tell me radius. What they did tell me is volume, which I have a formula that will help me to get radius, especially since I know the volume. So we'll put that volume in for V, so 7776 pi equals 4/3 pi r cubed. Now I know kind of in the other ones I was dividing by a number and pi at the same time. Technically I can do that here as well, but it's a fraction, so I'm going to divide them one at a time. Like the pi is going to go, because to get rid of a fraction I don't really want to divide it. I want to multiply by the reciprocal. So then we'll have r to the 3rd equals this crazy thing over here, which if I go back to my calculator, because again, big numbers, the first thing I try to do is divide it by 4. So I take the 7776 divided by 4. Please go. Yes. So it was divisible by 4. So now I can just times that by 3. So 5832. And then if you remember, we talked about in the other one, if I have something being cubed, so like r cubed right now, I can get rid of a cube thing by cube rooting both sides. And so if I leave this number right in there, then I can just hit the cube root button, which is next to the square root button, and it's 18. So my radius is 18. Which is so nice because then I can find the surface area by plugging in 18, squaring it, and then multiplying by 4. So 18 squared is 324. And then putting pi at the end. So times 4 is 1296 pi meters squared. All right, hopefully that extra circle practice was helpful. Even if not, I'm still glad I did it because we got to end on exactly 125, which is a perfect cube number, if you were curious. Anyways, sorry, I'm done. Bye.